All right. Well, that was a rather anticlimactic countdown. I forgot that the Jingle Bell song that I use is shorter than the normal one that I use. So, good morning, everybody, and welcome to a special holiday live stream. So, today we are setting aside our typical machine learning kind of stuff, and we are going to focus our time on the advent of code. And I'm even wearing my advent of code hoodie today. So that is what this is. So you can see that it's got like the ASCII like Santa hat, got my office decked out and all the Christmas gear and everything. And we're just gonna do the first couple of the Advent of Code challenges. I've already completed them. But really, what the intention of this to do is, this is a stream that's more intended for those who are beginners in programming in general, or more specifically, beginners in with Python. So if you're not familiar with what the Advent of Code is, so it is this 25-day challenge across the first 25 days of December, where there is like a coding challenge where you are given like a generic, or not generic, but like this Christmas like example with this input data set that's this text file with this random bit of data, and then you are supposed to figure out using like the clues that they give you, like whatever the answer to the problem is. And I'm probably doing a poor job of explaining it, but it'll make sense as we dive into here. So each day actually has two parts to it. So there's like the first part, which is the easier part, and then there's the second part, which builds on top of the first part. And sometimes the second part's really easy, and sometimes the second part can be a little bit more difficult. So I'll go ahead and share my screen, and we'll go ahead and get right into things. So this is the Advent of Code's website. So you can see that I'm actually not super far myself. I was at Disney World a couple weeks ago, so that kind of derailed my progress. I've actually only made my way through day 7. So the days progressively get harder. The first couple days are not too bad, and then it gets really difficult beyond like day 9, 10. So like I just started day 8. I'm not completed it yet, obviously. Day 8 starting to get into the territory of tedious, but not necessarily difficult. But I think last year, I think I left off with day 11 or 12. This year, I am committed to actually completing the whole thing, even if it means that like I'm gonna need to get help for myself. Because the nice thing about these challenges is that it helps you to build like some skills that you can then apply to other situations. So even though I focus in on the machine learning space, there have been skills that I've learned throughout my time with the Advent of Code here that I actually have been able to apply to my regular work. So this is actually, both a useful activity in the sense that you're learning new skills, and then depending on what your idea of fun is, I think they're fun. Like I think they can be really frustrating when they get difficult, but their early days can be fun. So let's go ahead and jump into day 1, or let me show you what day 1 looks like. So this is what they do. They give you a scenario, and then they give you an example of like how, like what the input's going to look like, and then like an example of like how to solve the input, and then they actually give you like the input data. So you can see if I just click on this here, I could actually save this as an input text files, or so that would be an input.txt file. So I already have saved this to my local machine. So this is all the data that we're going to be making use of for day 1. I know it's probably not easy for you to read right now, and that's okay. I don't necessarily need you to read this right now. But basically, I wanted you to build an intuition of, okay, so what is this Advent of Code thing, and why are we doing it? So this first part here, so like I said, they give you the scenario. So because this is day 1, this first part is just basically explaining what I just explained. Although it's giving you the Santa-ized version of it, the Santa-ized. I don't think. No, it sounds like I'm saying sanitized, but I'm saying Santa eyes. But anyway, so the actual scenario starts down here. So let's go ahead and kick things off. So the jungle must be overgrown and difficult to navigate in vehicles or access from the air. The elves' expedition traditionally goes on foot. As your boats approach the land, the elves begin taking inventory of their supplies. One important consideration is food, in particular the number of calories each elf is carrying, which is your puzzle input. So they're telling us that the number of calories each elf is carrying is going to be our puzzle input. The elves take turns writing down the number of calories contained by each of the various meals, snacks, rations, etc. that they brought with them, one item per line. So I'm gonna skip down here just to kind of tell you what here. So basically, what they're saying is whenever like the number of calories that they're carrying, so will be represented by a line. So this elf is carrying 1,000. This elf is carrying 2,000. This elf is carrying 3,000. And then you'll notice that there's a blank line, and so that's what it's going to talk about here next. So each elf carries their own inventory item from the previous elf's inventory, if any, by a blank line. Each elf separates their own inventory from the previous elf's inventory. Yeah. Okay. So I'm sorry, I messed that up a little bit. So basically, this is saying, like, imagine like an elf is carrying three, I don't know, granola bars. So this one's going to be like 1,000 calories, 2,000 calories, 3,000 calories. And then whenever there's a line break like this, then that's how you know that we're moving on to the next thing. So this first elf, he's carrying this elf is carrying 6,000 calories. Next elf is carrying 4,000. Next is 11, and that's what it's even telling us down here. So just to really that's the nice thing about this admin code is they really do try to make clear, like, or remove the level of ambiguity. So like we're not guessing here. Like it's actually saying, okay, this is 6,000. This one is 4,000, so on. And so, okay, so in the case where the elves get hungry and need extra snacks, they need to know which elf to ask. So they'd like to know how many calories are being carried by the elf carrying the most calories. In the example above, this is 24,000. So we are looking for who is carrying the most. Now, I just revealed the answer down there, but it's not going to be as easy to derive the answer. Like, well, I don't even mind showing the answer because like there's no way you're going to be able to figure this out just by like combing. Like I guess you technically could comb through the input text file, but like it's so long that it's basically like it would take you all day if you tried to do this by hand. Yeah, and I guess the other thing I should mention about this admin code challenge is it is written to be ambiguous to whatever coding language you want to do. So I personally am going to be using Python, but you don't have to use Python. If you want to use Java, you can use Java. I've seen some really creative people out there. There's one like jokey kind of coding language that like basically maps to like the commands read like rock ballad lyrics. So like after you execute all these commands, it looks like some weird like psychedelic rock ballad that Guns N' Roses would have put out or whatever. But so that gets creative, but I'm not that creative. So I'm going to stick with Python. And so I'm specifically going to do Python in a Jupyter Notebook. So as a reminder, if you are not familiar with what a Jupyter Notebook is, so this is the Jupyter Notebook interface. I've already started it up, and we are going to be starting from a blank notebook. But basically what like a Jupyter Notebook is it allows you to run Python code in cells, and like individualized cells, and allows you to rerun those blocks, and then you can also intersperse the blocks with comments throughout. So like, that would be the markdown cells here. So I could call this, day 1 elf calories, and then if I run this cell, so what that pound sign is doing there is it's basically saying this. I want this to be a header. So this text here is not a header, and so when I run this, then it shows up like normal text. Now, the reason that Jupyter Notebooks are so nice is for the data science community in particular is we can create data visualizations and whatnot, and then have them interspersed with plain text comments to explain what's going on. So I love Jupyter Notebooks. And I guess the reason I really like them for the Advent of Code challenge here is you can already see that as we loop through or iterate through the inputs that we receive from the Advent of Code, it's often easier to actually test one little piece out at a time. And so that's actually pretty easy to do in a Jupyter Notebook. So you can actually just run one cell and then run another cell. And then do them out of order just for testing purposes. Now, at the end, I do like to clean everything back up to make sure that, when you run the cells, they run in order. I've mentioned that in previous live streams before. That's the one pitfall of Jupyter Notebooks is if you're not careful, you can run things out of order, and that messes things up if somebody then tries to run it in like a sequential order. So we need to be careful with that. So the first thing that we need to do, let me just note, so I do already have the input.txt file here. So this is the same thing that I was showing in the stream or the browser earlier. Now notice here that so every single one of these is these things is represented as this bit of text here, and then we have like these breaks here at certain lines. The one thing I want to note here is that this is all text-based stuff. So these are not so data types are important when it comes to programming. So like whenever you do 1 plus here, well, let me go just show you. So let's say I have so 1 plus 1. 1 plus 1 is 2. Okay. So what I just typed there was just a plain 1 plus 1. Those are integer values. But if I put them in quotes, so this would be a string. So if I did 1 plus 1 as strings, now I get the string as 11. So that's why data types are important, and that's going to be an important consideration as we come into here, is because when we start to read in everything from this text file, this is all string-based values. So if we want to treat them like numerical values, we are going to have to change them appropriately. And the way to do that is actually pretty easy. So the way to do that actually that we're going to be doing is just using this built-in command from Python that just says int. So if I pass an int and then I do 1, 2, 3, and then it returns back that I know it's hard to read that. It's hard to tell if that's actually an integer, but I assure you that's an integer right there. Okay, so the first thing we need to do is actually we need to load in the file. So the way that we do that is we are going to use another built-in Python operator called the open command. Now I like to just use this with command along with the open command that just because what you could do, and this is what the temptation of some people is to do like file equals open, and then in the string you would actually put the file name there. So file equals open this. The reason that you don't want to do something necessarily like this is when you run this cell, then it is basically in memory that file variable there has the same text file open. And so then it kind of creates a risk of we can make edits to that file and that we might not want to make. So the actual better way to do it is to grab the contents of that file and save it into a variable and basically close out this file as soon as you can. And so the quick way to do this is this with command. So with open so input.txt, and then you can actually pass in a second parameter to make sure that is really only in the read-only capacity. So to make sure it's only in a read-only capacity, we're going to pass in the R. So R stands for read. So as f. So that is so this is saying with this file, and we're going to refer to it as f, or we'll just call it file just to make it a little bit more clear. So with this as f, then I'm going to say elf calories, because remember these are representing elf calorie packs. Elf calories equals file dot read file dot read. So actually I'm going to start there because I'm actually going to elaborate on this. I just want to show what this looks like real quick. So if I just type in elf calories now, elf calories. Okay, so now you can see that it did something kind of a little bit goofy looking. And so what you can see here is that it's got all these what are called new line characters. And so that is represented by this \n. And so even though in our file here we can't see that, the way that the text file knows to go to a new line is there is like this invisible \n character representing the new line, and that's how you know to go to the new line. So that's why I went ahead and did it like this. Now there's actually a different way we could actually read this in that would actually appropriately does this split for us. So and this is why I like to do things in a Jupyter Notebook, because then we could just simply rerun the cells. So instead of just doing the file.read, we do a file.read.split lines. And so now when we run that again, now you can see we have this. Well, this is a list type. So we know it is a list type because it is braced by these bracket. It has this bracket on the left side, and then if I were to scroll all the way down, it would also have like a closing bracket on the right side. But now you can see that we have all these individual things here representing the individual calories. Okay, so pretty simple. So and again, this is actually going to be a fairly simple challenge here, because basically all we need to do is we need to loop over all of these calories and just keep adding them like up until or grouping, or basically like adding them up, and then whenever we hit like a break, then we like stop like the adding, and then like because that represents the one elf that's carrying things. I'm explaining things very terribly right now, but it'll make sense here in a second. So so what we need to do is I'm gonna create a new I'm gonna put instantiating instantiating a list to hold the elves total calories held, and I'm just going to call this calories or elves. So remember, so basically what we want to do is we want to take 15560 3906, basically these 5 values, add them together, and then put them as one value into our list. So then we'll have a list of all these different elves. So that's why I'm doing this. And now so that is that. And so we need to iterate over every single elf calorie in here. So what we need to do is use a for loop. So what a for loop is basically saying, okay, so we have this whole list here, and we want to go over every single thing in here. So the syntax for that is for whatever you want to call it. So I'm going to call it for calorie pack, and I'm very descriptive with my variable names. You don't have to be this descriptive. Some people will go as simple as for I in elf calories, so we're looping through the elf calories. I think that's too ambiguous. I purposely like to go a little bit more specific. For calorie pack in elf calories, and I'm trying to think what is the best way to do this. Okay. All right. Oh, I need to instantiate another value. So instantiating a value to represent calories held. I'm having to remember some of this off the top of my head. All right. So we do need to have another value, because basically what we're going to do here is as we loop through our packs here, we're going to increment this value here. So we're going to start it at 0, and we're going to just keep adding this. And then once we hit one of these breaks, then we're going to take this aggregated calories held value, append it to this guy, and then set the counter back to 0. So then we can start the process over. I hope that makes sense. That'll make sense here as we continue along. So by the way, I am monitoring the questions or the chats across both LinkedIn and YouTube if you have any questions. So feel free to drop those if you have any along the way. So so for calorie and calorie packs. All right, so for the first thing we need to do is changing the data type from string to integer. Well, actually, no, I don't want to do that yet. So the one what do I want to do here? No, well, okay, so if calorie pack not equal empty. Okay, so I'm gonna kind of skip ahead a little bit, and this word right here, pass, is a keyword in Python that basically says, okay, it's kind of like a placeholder value that says don't do anything, like I need to come back and write this code. But basically, so what this exclamation equal sign this exclamation equal sign symbol stands for is like not equal to. So if this, basically what I'm saying is, if the calorie pack does not equal one of these breaks, then we are going to do like the incrementing of this calories held. But I'm going to skip this for now because I want to do the actual, like, if it does equal the line break here. So remember, this would represent that here. So if calorie pack equals that, then what we want to do is we need to append the calories held to the elves list, because that's going to be our collective thing for that individual elf. So elves.append. So what we're doing here is basically once we've hit one of these breakpoints, assuming that these calories have been aggregated appropriately, we're going to take those calories and append them to this elves list up here. So elves.append calories. Why did I put calorie held? Calories held. And then we need to reset the counter. Resetting the calories held counter, because we want to reset it for the next elf. So resetting the calories held counter. All right, so calories held equals 0. Okay, so that's that. Now, if in the case where it is not blank and it is an integer value, like it's a it's like we need to add it to our calories held. So the first thing we need to do is we need to changing the data type from a string to integer. So as you can recall, that's going to be calorie pack equals int calorie pack. So that calorie pack. Okay. So let's back up for a second. So as we loop through here, I'm going to put a iterating over all the calorie packs in elf calories. Handling calorie packs appropriately, aggregating calorie packs appropriately. So I am very notorious about like making sure that I robustly annotate everything. Okay, so just as a reminder, so as we iterate over these calorie packs here, so if it is not empty, one of these empty strings, so again, that would be any of these numerical values. The first thing we need to do is we need to change it from a string type to an integer. So now it's an integer, and then we need to actually increment this value here. So the way that we do that is, so incrementing calories held. So calories held, the shorthand to do that, because you could do calories held equals calories held plus calorie pack. So that's the long way to do it. I prefer the shorthand. So the shorthand to do this is actually calories held plus equals. So that's basically saying, okay, I want calories held to equal this plus whatever this is. So, and that's basically the whole code, or at least the code that will get us how much each elf is carrying. And again, if it's blank, then we take the value that is currently held, we append it back to elves, and then we set the calories held counter back to 0. So let's go ahead and run this cell, and then let's go ahead and view our elves thing here. Okay, so now this is a whole list of value all representing the number of calories held by every single elf. Now things get pretty easy from here. So this is let's go ahead and print out the type of this. So this, as a reminder, is a list, and Python has some default functions that we can use against a list. So one of those functions is the max function, and if you can recall from our thing here, is we are trying to figure out what is the total calories that is held by the elf that is doing the most. And so the answer is 69582 or 528. And so the way that we get that is max elves. And so there you go. That's the answer. So that one's actually a pretty easy one. So 69528 is our answer. If we wanted to make this a little bit cleaner, I would say print f. This is what we call an f string, and the reason that we call it an f string is because we can have some normal text, and we can say calories held by the elf doing the most, and then within these curly braces here, we can actually take this, or we can pop in the same thing here, and then that will actually produce like the actual, like the variable's value. So so again, that is using before, like within the, so let me just show like a typical print statement. So a typical print statement is hello world. This is a string within single quotes, but you could also use double quotes. Doesn't really matter in Python so much, although you can't mix match them. You can't have like a single quote on one side and then a double quote on the other side. Sorry, I was just looking at the comments on YouTube over there. But if you wanted to combine like the straight string value with like one of these variable values, then you just stick the letter f there, and that's what we call the f string formatting. Okay, so that is part 1 of this day. Let's see what is part 2. So part 2, by the time you calculate the answer, they've already realized that the elf carrying the most calories might have eventually run out of snacks. To avoid this unacceptable situation, the elves would instead like to know the total carried by the top 3 elves carrying the the most. That way, even if one of those run out of snacks, they still have 2 backups. All right, and then it shows another example. So how many calories? All right, so find the top elves carrying the most calories. So this one's actually pretty easy. So basically it's saying, okay, we need to find the elves that are carrying the most. So the way that we could basically just continue off of what we already did here, because if you recall, this is already the list of the elves that are already carrying the most. So the only thing that we need to do is really just grab the first 3 the top 3 elves. And so the way that we can do that is we can use another function in the list, is the sorted function. So I'm going to call this sorted elves equals sorted. So this is a default Python function, and so we pass in elves, and then I actually am going to pass in this other parameter called reverse. So reverse equals true. And so then if we look at sorted elves, then it'll the reason I did the reverse equals true is because I wanted the largest values to be the front. So there's our 69528, and that was the answer to our first question. So basically we need these 3 here. And so I am actually just going to grab the top 3 elves by doing some list operators. So when it comes to these list values, you can actually reference these individual index values, or these individual items at their index value. So basically what I mean by that is, so if I wanted to get at 69528, within a bracket here after the list, I can pass in whatever that index position is, and it will give me that value. Now, indexing in most programming languages, including Python, actually starts at 0, not 1. So if I were to pop in a 1 here, this would be 68787. So let me go ahead and demonstrate that. So if I pop in a 1 there, and then if I pop in a 2 there, then I could do that. So there are a couple ways we could do this. So we could just, if I want to do it the simpler, or the easier to understand, but kind of the less fancy way to do it, I mean, that's the answer right there, right? Yeah, that's the answer right there. So that's not the best answer. What you can do instead is you could do the sorted elves, and then using a string operator, you can, like that. So if you basically, what the colon is saying, okay, I want everything up to index position 3. So that's saying, okay, I want 1, 2, 3. So then we have the list of just our 3 values here. And then we could even wrap this even further around another default Python function called sum. So that's basically going to take the sum of our list here. So sum, and I'm going to wrap this around here, and then we get the same value as above. So so again, there's more than one way to do things. I would actually say this latter way is probably the better way to do things, because it's easier to type out. Because you could imagine, let's say we had to get the value, the first 50 of these. So here I can just get the first 50 like that. Imagine trying to copy and paste this nightmare up to 50 times. Like, that would take freaking forever. So that's where this is actually it's much better to learn these things. And that's where I was saying, again, the advent of code is really great for learning these sorts of things, because these are the sorts of things that you can then take in the back and to apply to your regular work in your real world. So that is day 1 in the books. So let's move on to day 2. And I don't know how many of these we're going to get through. Maybe we might get through 2, maybe 3 tops. We're already 30 minutes in. So yeah, so that is that one. So I'm going to go ahead and leave that. I'm going to go ahead and delete this notebook since I don't need it. And I actually think I did this one a little bit differently. So this is my actual one that I did, and you could actually see what I chose to do instead here I actually chose to change the blank values to the 0, and then I changed the whole thing to integers before looping over everything, and then everything's pretty well the same after that. Yeah, this is all the same after that. So more than one way to solve these things. That's why these challenges are really interesting, and it's interesting because there's like a subreddit too that for the advent of code, and it's interesting to watch people and see like what they do with their own code and stuff. Okay, so that's day 1. On to day 2. So I already have a lot of these downloaded. Okay, this one's a little bit heftier, so we might not get through more than this. So I'm going to call this day 2 stream. All right, day 2 stream. And again, so let me go just show you what this input looks like. So, and then we'll actually go to the advent of code here and show you what this looks like in the actual advent of code website. Okay, so day 2. All right. So the elves begin to set up camp on the beach to decide whose tent gets to be closest to the snack storage. A giant rock, paper, scissors tournament is already in progress. How ironic, because we've been doing that rock, paper, scissors project. All right, rock, paper, scissors is a game between two players. All right, so this is basically just describing what rock, paper, scissors is. And if you all have been following my streams, you all know what this is. Come on, people. I'm not going to cover this. You're welcome to read it if you want. So adminacode.com, by the way, if you didn't catch that up at the top there. All right, appreciative of your help yesterday. One elf gives you an encrypted strategy guide. And so this is our puzzle input. And that they say will be sure to help you win. The first column is what your opponent is going to play. So A is for rock, B is for paper, and C is for scissors. And the second column, and then the elf gets called away, and we don't know what the second column is. So the second column, we reason, is what we need to play in response. So X equals rock, Y equals paper, and Z equals scissors. So winning every time would be suspicious, so the responses must be carefully chosen. The winner of the whole tournament is the player with the highest score. So the total, your total score is the sum of your score for each round. The score for a single round is the score of the shape you selected, 1 for rock, 2 for paper, and 3 for scissors, plus the score of the outcome of the round. Okay, so side commentary. Obviously, you know, they're giving you the input and they're telling you what you need to do. Why would you just not pick scissors every single time? Because even if you lost, like, because you don't, like, assuming that the other person is random with their choices, like, there is a, like regardless, like, I don't know, I'm just playing the game theory here. The only logical sense that it would make if the other person's going to be random every time is that you choose scissors every single time, because you're at least going to get 3 points for scissors. So that's what I was thinking the entire time whenever I was doing this for the first time. Anyway, sorry. So anyway, outcome of the round also is if you lose, you get nothing. You get 3 if it's a tie, and 6 if you win. Since you can't be sure what the elf is trying to help you or trick you should calculate the score you would get if you were to follow the strategy guide. So here's the example. So if they played A, so A, that would be rock for them, and we played Y, that would be paper for us. So we would get a total of 8 points because we chose paper. That would be 2 points because we chose paper, and an additional 6 points because we won. So a total of 8. So hopefully this makes sense. Now this one's kind of, it's not hard. It's just time consuming. Like, I think I actually did this one on the plane to Disney World. So, like, I remember very fondly the guy sitting next to me just kept looking over my laptop like, what the heck is this guy working on? Okay, so let's go ahead and hop into our notebook here. So the first thing we need to do is we need to import our data. So we're going to do the same thing we did with our previous one. So importing the rock, paper, scissors, RPS. I'm going to call this RPS because I'm shorthanding it. RPS games from the input file. Okay, so as a reminder, that is with open input. And then we want to be in the read-only status as file. And then I'm going to call this RPS games equals file dot, and then remember it's read dot split lines. Okay, boom. Now let's just go ahead and look at it just so we are familiarizing ourselves with it. So these are string values, bunch of different values that are representing our games here. So I'm actually going to build some helper functions here to actually help us out. So the first helper function, so what a function is basically, you know, you put in something, think of it like a recipe, like you're baking something. A function would be, or like a bread machine, for example. Like, so your inputs to the bread machine would be yeast, flour, whatever goes into bread, and then out the other side comes baked bread. So what we are going to be doing is I'm going to be creating a couple of different helper functions. So the first one I want to do is I want to remap these values to be what they actually are, just so it's a little bit easier to understand. So basically I want, you know, we know that all A's are going to be rocks. We know all X's are going to be rocks as well. So I just want to remap those. So let's go ahead and write this in Python. So the way that we do that is with this def keyword. I think that stands for definition, and then we can actually define the name of the function. So I'm going to call this remap RPS input and then we are going to take in the current mapping. So and that will be represented by this character right here. All right, now, so, and then after the colon, I'm going to do 3 quotes. And so what this is called here is a docstring. And what a docstring is basically it's a small bit of documentation about what the function does. So typically what you do with the docstring is you provide 3 bits of information. You provide what is the general purpose of this function, what are the inputs of the function, and what are you getting out of the function. So so the general purpose of the function is remaps the values from A, B, C, X, Y, Z to a more understandable rock, paper, scissors. Okay, so that's the general purpose of the function. And then I'm going to put the inputs. Inputs are current mapping. And then after the input, it is typically good practice to also put what the data type of the input is. So in this case, it is a string. And this is going, and then a little bit more of a description of what this is. So the current input choice provided by the player in ABC/XYZ form. All right, so that's the only input, and then we're gonna respond back. What is it returning? And that is going to be the RPS choice. That's what I'm going to call that. And this is also going to be a string, and this is going to be a more understandable rock, paper, scissors choice. Okay. Now, so the way that this is going to work is just basically some fancy if-else statements. So basically, so I guess I didn't explain this well in the previous one. So in Python, we have these conditional statements that basically say, okay, if this thing has this value, then do this one thing. If it has a different value, do another thing. And we call those conditional statements. And so those are represented by ifs or elifs. So an if statement is basically starting off the conditional. So so we're going to start off the if a or x mapping to rock. So this is basically saying, okay, if current mapping equals a, or current mapping equals X. Now, I guess that's the other thing. I keep forgetting to explain things well, so I apologize for that. So the one thing that I did want to note here is there's a difference between the single equal sign and the double equal sign. So when we actually do a single equal sign, that is saying, okay, we want this thing to be assigned. So this is the equals in a, like the single equals is kind of an assignment operator. So we are assigning whatever this is to this value here. Whenever we have the double equal sign here, we're actually doing a comparison to make sure these two values are equal. So and it's basically saying, is this true? Is this not true? So this is saying, okay, if this is true, so if this current mapping that we're passing in, if it is the letter A, or if it is the letter X, then this next bit of